Welcome back, geometry students. Today's notes are titled 12-4, Inscribed Angles. All right, there are many different kinds of angles in a circle. This is just one kind that we're going to talk about today. We'll have more tutorials on different types of angles in a circle. These are inscribed angles, okay? And let's talk about what an inscribed angle is. First off, the inscribed angle has the vertex on the circle. Okay, unlike a central angle that has the vertex at the center of the circle, an inscribed angle has a vertex on the circle, like here I have in my example. Okay, and if you remember that the inscribed angle has the vertex on the circle, on. The vertex is on the circle. Okay, let's find out what the measure of an inscribed angle is. If I have an inscribed angle here, like in this circle, it's 35, and then the arc that's created here is 70. So as you can tell, the measure of the inscribed angle is equal to half of the measure of the intercepted arc. Okay, remember what an intercepted arc is. With this angle, the intercepted arc is where the angle intercepts the outside of the circle, so this arc here. So this arc DC is called an intercepted arc from the angle we have. Okay, clearly 35 is half of 70, and so the inscribed angle is half the measure of the intercepted arc. I could also go backwards. I can know that 70 is double the measure of the inscribed angle. Right there. Okay? Let's get some examples. I have 4 examples, and I'm going to, if you want to pause the video and copy these examples down first, and then we can come back and solve them. I'm going to zoom in a little bit on my first 2 examples as we go through those. So my first 2 circles here. The first one, I have my circle F, G, and E are the points around the circle, and I want to find the inscribed angle if I have an arc out here that's 156. I'm going to change this from a question mark to X. Okay, that's what I need to find. Well, I know that my inscribed angle is half the measure of the intercepted arc, so my angle X there is going to be half of 156. All right, and half of 156 is 78 degrees, so the value of my angle FGE is 78 degrees. Okay. Another example is if I have a circle here, I'm going to try and find this angle here, angle QRS. I'm going to call that my X. All right. The only thing I know is that my angle down here, angle QCS, is 91 degrees. Now, a lot of times circles, they're kind of like a puzzle. You have to say, what do I have and what do I need and how do I get from what I have to what I need? Well, in this case here, I see that I have an inscribed angle is 91 degrees. Find the intercepted arc. So if I take this angle here, it creates my arc SRQ. Okay, and if this is 91 degrees, I can double it to get my arc out here. So 91 doubled is 182. Okay, and I want to find my inscribed angle back here. So if I know the intercepted arc for that angle, I can then find that. Well, I can take into account that all of the circle is 360. If this piece is 182, 360 minus 182 is going to give me 178. And that's for my arc QCS. All right, and then I can solve for X. I know X is going to be equal to 1/2 of 178 degrees, and that's going to be 89 degrees. Okay, so kind of like a puzzle again. It's from the 91 degrees, double it to get the arc out here, and then find out what's left over with the other piece, and then cut that in half. All right, 2 more examples. My first one has a lot of lines in here, and sometimes they give you circles with extra lines. They give you an extra chord here, XY. They give you chord ZY. We have another chord EY, and then a diameter XZ. So we have a lot of line segments going on. I need to look at this and say, okay, what do I have, what do I need, and where do I need to go? Well, I can see that I have this inscribed angle. It's what I want to find. If I call that X, all right, and think about the intercepted arc. So follow this angle out. Okay. If I know the measure of my arc XY, I can then find the measure of the angle XZY. All right, well, I have 35 degrees. I can start there. If I have 35 degrees, I can follow that one out. Okay, I have the arc, I have the angle, so find the arc out here that's made by that. That's going to be double 35, which is 70. Okay, then knowing that XZ is a diameter, this semicircle is 180. So I could take my 70, take it away from 180, and so I know that this arc is 110 degrees. All right, then I got to find x. X is going to be half of 110. So x is 55 degrees. All right, hopefully that makes sense. The next one here, my last example. This one involves an algebra expression, 9x plus 12. 9x plus 12 is this arc. All right, and the angle that creates that arc, or the inscribed angle here, is 51 degrees. So the reason why I've been writing all my expressions here, x is half of an angle here, is for this problem right here. I have this angle is 51 degrees, and I have something here. I need to solve for x. Okay, so I can set up the same way. I know my angle, 51 degrees, is going to be equal to half of my intercepted arc, which is 9x plus 12. All I got to do is solve for x. Now again, remember in a previous tutorial, I took both sides of this equation and multiplied by 2. So that would give me 102 is equal to 9x plus 12. Some of you guys are like, I really like distributing that 1/2 because you know how to distribute. I'm going to do that this time. It's correct either way. So if I distribute that 1/2, I'm going to get 51 is equal to half of 9x is 4.5x. And then half of 12 is going to be 6. Okay? Subtract the 6 from both sides. So I have 45 equals 4.5x. And if I divide by 4.5, 45 divided by 4.5 is 10. So x, in this case, is a value of 10. And the question was said solve for x. I can plug that back in to make sure I did it correctly. 9 times 10 is 90, plus 12 is 102. And again, remember that 102 is double what this inscribed angle was back here. So I know I did it correctly. All right? So make sure you get all those notes copied down into your journal. Don't forget your WSQ. Bring them to class the next day. Have a great day.